when carriers have been discussing feeding their AI, a lot of times I've been hearing they're building a lot of big data lakes. A lot of times the data sources from multiple silos, and it's very convoluted and often updated only once an evening. When I talk about contextual data, I'm talking about data that's real time, that has both who updated it, why, when, but more importantly, it tells you how many times it might have been updated. I want to know if it was updated, if it fell out, was it updated manually? Was it updated through an automated process? I want to know all that context, and that's the piece I think people are missing in AI right now.
Yeah, I'd agree. It really depends what kind of decision you want to make. Sure, if you're making decisions on monthly cycles,
Right.
Even daily cycles, that's fine. But a lot of the decisions you actually need in the network, they're real time. Unless you are literally addressing a security concern at the time that it's available, you're too late. The bad guy's already inside your infrastructure or whatever else it is. So I think that contextual real-time data and decision making based on real-time data is critical. We've been living in a data warehouse, data lake situation, and we all know the horror stories of that one of lots of data in, but very difficult to get that data out. Right. So it's not just timeliness; it's also actually just being able to sort it, organize it, and make it ready for decision making. That's
exactly well said.
So Bob, in a recent blog, you talked about the context of data in terms of making autonomous decisions. I'd just be keen to get your sort of view as to what's underlying that sort of thought process. Why do we need to go deeper into actually being able to enable autonomous networks, and where we are now is not yet ready for that?
I think one is the data readiness. I think we're also, one of the elephants in the room that I see is around just having access to that real-time data. We kind of talked about that before, but without that real-time data in a contextual way, you just can't make those decisions. And you want to be able to not only enable automation, but you want to enable the humans in the process.
And so that they actually trust that decision making, because otherwise,
correct.
We'll never automate. I think that human it's not just human in the loop; it's human in the trust that is actually the key aspect.
Correct.
Yeah.
So one of the things we want to make sure is we can help the folks, the humans in the OSS BSS process. Now, one thing about contextual data is you also want to put it into what we call a contextual ontology.
Yep.
This data needs to be rendered in a model that it stands together, where I can update individual entities of the model, but it still holds together the shape of the model.
Yep.
And that ontology is what AI needs to see. And that's the piece you want to continuously update in real time, where AI can see the insights of how this model is being updated. I don't want to just see a snapshot in time once a night. I want to see it every second, every millisecond when I'm getting into the network data.
Yeah, one of our key research areas is digital twins, an example, and what you're describing is really the sort of foundation for that digital twin. Is AI is not just making decisions; it also needs to validate the kind of decisions. Particularly if you're looking at non-deterministic or stochastic type decision making, by definition it cannot always be right. So how do you not only make the decision but also validate what the consequence of that decision is in the network? And that's where the ontology is really the foundation of the digital twin. In our recent research, we identify 6 parts of the digital twin. Ontology is number one in that area. How does this data relate to this piece of data? How do they fit together? Through time, through space, as it were.
Exactly.
That is critical to that kind of foundational digital twin for the network.
Perfect.
So, Bob, one of the areas that we're particularly looking at the moment is this whole idea of security and network convergence. They've very much been very distinct entities, be it in terms of enterprise and in terms of telco, but it also increasingly within telco. The security of the network is always seen as a separate department, separate set of information. Now, that was fine when networks were really hardware, but that changes very rapidly in terms of software. This idea of security and network operations convergence is very, very important. And again, there's common data between what you now need to do in terms of managing the network and what you need to do in terms of managing the security of that network or the enterprise applications that are on top of that one. So again, coming back to the whole idea of ontology, security security you could almost see as another network domain almost that needs to sit and sit with the rest of the thing. How do I see something like a threat coming in? How do I instantiate that in terms of its relationships to where pieces of software are in the network and how we're connected to? How do I relate that to what is being seen and from a security dashboard versus what is being seen from a network dashboard, which at the moment are very, very separate things, but actually increasingly need to see views on each other and how that fits together. So I'd almost sort of say it's that sort of, how do we bring the data from what has been very siloed operations together is the way in which you address this whole aspect of timely, secure networks and delivering them.
And what's nice about the ontology and keeping this in real time is we're able to segregate data as needed in locations. Also, we can, I wouldn't call it security, but we're able to keep the ontology model secure by enforcing schemas and who can update data and who can consume it. So we know with AI, we don't have to give it access to the entire ontology. We can give it a sliver, and that's often a good thing. Give it AI too much data, a lot of times it can make some hallucinations, where if you can focus it in on specific questions and data, that becomes more secure too.
It's both having the whole picture and actually being very, very specific about the picture that you're actually trying to address.
Right. So Francis, with the ontology and building out this new schema-driven architecture, it would seem like it would be a big uplift to move telcos from their current siloed databases, their current point-to-point interfaces to this. But we think it's more straightforward, where we can slowly move processes over where they can leverage this event-driven pub-sub model against a true ontology-driven architecture. That data is then available to the AI. So you don't have to do a big bang migration to this ontology. You can slowly move processes. And we even talk about a way to free your data where you can keep your current processes, but we will replicate and build a shadow of that in the ontology that AI can consume.
And I think that's a common thing. It's actually a common thing in a lot of my history in dealing with OSS systems. The worst thing you can do in the world is kind of try to do everything in a big bang. Big transformation. I've got too many scars on my back from sort of trying to attempt to do that.
Or they fail, and you got to roll back.
Absolutely, they fail, and I think data is no different. But the nice thing about data is by putting that kind of mechanism of distribution and routing to wherever the situation needs to be, is that you end up with an ability to coexist, as it were. In fact, you can start to push stuff into the new way of working and then push it back into the disintermediation layer in between. So you're getting the best of both worlds. You're able to keep people on the process that they're used to and migrate over time in that situation, but enable the new use case. And that's probably the most important thing. It's pretty pointless just replicating what something already does, but it's really exciting doing something new.
Exactly right.
We're seeing a lot of talk about things like agents, agentic thinking at the moment. One of the areas I think telco hasn't yet done, but is almost critical to this whole idea of really taking it on is what do we deal with in terms of collaboration with agents, but actually more importantly, conflict between agents. And that's where this real-time data source and context comes into mind. When is it the right... let's take three things that typically need to be balanced in a radio access network. There's energy usage, there's customer experience, there's capital expenditure on the thing. There are different points at which it's very easy at the moment to build very rigid rules about customer experience always trumps energy. But actually that's not. There's times when you get massive energy improvement, very minimal customer experience. You want that context. And that's where that real-time model, what is the context for a particular cell site or whatever comes into mind. So I think coming back for us, that sort of adoption of agentic AI comes into when we start talking about how do we resolve conflict, how do we increase cooperation between agents. That's key thing for us.
And we're trying to define agent roles that emulate roles that maybe a human might have in today's world. So if it becomes more of a helper of the human and transitioning to it.
Yeah.
And then we talked about ontology and context and knowing why and when something was updated. This becomes even more important when you have agents doing it. You want to know what things happened for good or bad. I want to know how it happened and why, and then be able to track it.
Absolutely. It's part of that process. Is we will only get agentic decision making accepted when we understand human decision making. I think a lot of the challenges at the moment, we don't tend to actually understand when humans are making bad decisions. We kind of have a very black and white situation. We need to understand agentic will not necessarily be 100% accurate decision making. It will be better decision making than we are able to do with humans, and that's a coexistence thing. But that is also a traceability is a data thing. What decisions did we make? How do we track them?
Perfect. Well, Francis, thank you.
Thank you, Bob.